Okay. And then you have a solve a Leetcode 207 course scheduling. Basically, the question we're gonna say amount courses, right? Course B and a prerequisite. Into A B I amount course A and the amount course B, right? And I need now a list, array of a list of this, right? Into course A, course B. Before I be to my course B, no, I just say why course A. In A B this is the entire list. A B assign D Z, right? So before I be D, no, before I be to my Z, no, I just say why D, right? Into the say sa array ya de ama we no, right? Hwɛ sɛ wobɛtumi ayɛ courses nyinaa na sɛ wontumi nyɛ courses nyinaa based on relationships yɛm de ama wo nyinaa return false, right? If else return true. Into hwɛ we a example we mama we see two courses per na right? Na two courses no course 1 and a course 0. Before I be to my course 0 na just say why course 1, right? Into no when we say right into no directed basic and we say some of my course second exam into no way no bit my right which might take course 1 we are not quite course 0 and no matter my another example say course we or 1 0 in your 0 1, right? We say no so an example na quite say 1 no quite 0 and almost I say 0 no quite 1. We say no interchangeable, right? To mean yet before I submit my 0 I say 1, before I submit my 1 I say 0 into won't mean your shade into no when in an ababe say won't mean your course way you can't finish this course into no so ababe force what I saying, right? But usually when they give you a question like this, scheduling, prerequisite and all of that now, a graph, right? O should do my end say way now, way maps to way maps to way now. We'll be to my arranging in like adjacency graph. Into the one of the first things you need to know is adjacency list, right? The second thing you need to know is in degrees. I've done a video about this. There should be the video so about in degrees and so on. And then the algorithm and kasa you need to solve a question like this. We here to solve a question like this near friend topological sorts. This is the type of algorithm we here to solve these kind of directed into almost a way saying you can say before you can do this you have to go here, before you can do this you're directed, right? And it's a form of a graph, right? Into a directed graph which might say in doors I won't say eventually in the baby be say right a baby say na ba a graph into and maybe we quasi maybe we quasi right into the one chain honey na we say na directed into which my way asana bit to my way na just say why way asana bit to my way no you say why way, right? Directions. So this is some sort of a directed graph. Into you find say where course 1, where course 2, where course 3, where course 4, course 5, course 6, course 8, right? Into you directed asana bit to my 1 I just say why 3. Asana bit to my 4 no asana bit to my 1 I just say why 2. Asana bit to my 4 I just say why 3, right? Asana bit to my 5 I just say why 4. Asana bit to my 6 no I just say why 4. And then son I bet my 6, no, I just say why 8, right? Until that BB course na kwa BB say no. And so we're converting it to adjacency list. And how you convert it into adjacency list now? By a video on how you bet my convert a graph no into adjacency list, right? And you know, something like that. The things again, Nyama say adjacency list in degrees. In degrees, no video on my way to me. I share no what I say, but brief understanding is in degrees no. Offer one say one no, it will 2 in degrees because 2 and ever inside, right? 2 and ever into 1, right? And I say no so 4 no so in degrees 1, which will in degree 5, right? Now which will in degree no 1 what I say. In degrees no. Directions are ever into the course, right? Yanko share topological sort now how we can implement topological sort. But first, read a little bit about topological sort and how it is used and what are the scenarios that it is used for. Scenarios like this, questions way like this, no, right? In the directed graph, normal person will sort it in an order. Just say you take all the ones needed before you take the ones that are that come next, right? Solution first of all, no, you create the adjacency list for this question. And adjacency list default text list, right? Basically, I'm creating a dictionary of a key and then the values, values in a list, right? Say no, a simple way of representing a dictionary with a key value pair. In case any enter, in a dictionary of a key, and then a value will be int, right? And for every prerequisite in a course, right? In prerequisites, adjacency adj lists prerequisites dot append course. In degrees now, I can no. Find in degree, so equal to 0 times number of courses, right? In degree course also equal to 1. Plus 1, right? So it means a course way. I just want to take a prerequisite way and some what take is our course way there. The in degree will be increased by 1, right? And here we are. Course any in degree and in degree value near 0 piano. As a chair says, our course no with my fan first, right? Which has here course we in degree is 0, we in degree is 0, 2 in degree is 0, 3 in degree is 0, 5 in 8 in degree is 0. These are all courses that you can take first because need now a prerequisite, right? But when in degree 1, we cross in degree 1, so you can't take 5 because in degree 1. 8 in degree behind in no wait might take 8. And 2, 3 and 8 and no now wait might take in the first, right? Into the next step now, I have a final course na any in degree beyond into for prerequisites in range of number of courses. If in degree course is equal to 0, it will create a queue. First, let's create a queue because may use BFS na their solution. So Q is equal to the Q into now. So in degree is 0 and we had back Q no because Q is Q no and the best start here pick courses now from into Q dot append course. Yeah, for each course in num courses range, if in degree course is equal to 0, append course, right? In the CNI BFS, breakfast search, right? If Q, now in creative variable courses taken. If Q prerequisites is equal to Q dot pop left, right? Into Q dot pop left. And you pop Q area, and I mean say it may increase course taking. Courses taken by 1. Into again adjacency list no value na ya fast is here Q ya pop no a value in the dictionary na ya form wa say no into each value no a corresponding list a key, right? Prerequisite ya pop no a key in this adjacency list. The value no a list into see I loop through that list, right? For each course in ADJ lists, prerequisites, say adjacency, say in degree no, of that course, you better one a frame because in your take is our course no. In your take is our course we prerequisite where I mean say the in degree no swat by 1, right? Now say if it's in degree no so by 1, now say in degree no it be equal to 0. It means that our course no you ready say bit my take is our course no here the back Q no. Right? Here they can Q no one. The next step then say yeah way in area. It will only be true if num courses is equal to courses taken. Okay, so like I said earlier no, look more into topological sorting. That is the algorithm I had to solve a problem like this. I say, oh, okay, That's great. So this is how you solve Leetcode 209. Again, adjacency list, integrates, and topological sort. Those are the ingredients you need to solve this question. All right. Thank you. Bye-bye.